let's say we are asked to integrate arcsin x dx. One thing we should always remember when we give an arcsin is that or whenever we are given an inverse trig, we would use integration by parts. So the integration by parts has that rule, which we can call it the golden rule or whatever you want to call it. Ln x raised to n e x and trig function. So whenever we are given a function, we check for these things. If we've got ln x is going to be f at x if is matched with x squared or ex or any trig function or something else. X raised to any exponent would be f at x whenever is matched with this function and a trig function or any other thing except for ln x, as well as ex and trig. The rule will apply. So now if we're given an inverse, we want to rewrite this. We remember that there is 1 here, so we want to say 1 times sine inverse of sine, x dx. Why we're doing that? It's because we want to find out f at x and g prime x. So in this case, 1 is not part of this rule, so arcsine is part of it. So that means arcsine will be f at x and 1 will be g prime x. It's easy to go about when integrating 1. We know that our g at x is just going to be x. Now let us come to arcsine. We want to differentiate here. I think you're gonna remember the rule that says when you differentiate the inverse of sine, you must remember that this is gonna be equal to f prime x over a root of 1 minus f at x squared. So don't confuse this f at x with this f at x. This f at x is from this x that is here. So our f prime x, it's a derivative of x. So let's go and write the f prime x there. So f prime x is the derivative of x, right? Which is 1. 1 minus f at x. We said f at x is x squared. So we put the root there. Then that's how we would go about differentiating arcsine. Now we can apply the by-part formula, which says f at x times g at x. So our f at x is the inverse of sine times x minus, here we would have g at x multiplied by f prime x. G at x is x multiplied by f prime x, which is 1 over square root of 1 minus x squared. Then we integrating there. So when we continue with this, we want to rewrite that as like this. Now here we would have x 1 minus x squared and the root, then dx. So we want to integrate this. For us to be able to do that, we need to remember the formula that says if you have a function which you see that you've got f at x that is enclosed in big brackets and raised to a function and raised to a certain exponent, multiplied by f prime x dx, then this formula says you would go about integrating this by taking that f at x raised to n, you add 1 there, then you divide by n plus 1. So on our case there, we need to rewrite this in that formula. So let's do that. X sine inverse of sine x minus, so we want to put f at x. F at x, our f at x is 1 minus x squared. A root is 1 over, it's minus 1 over 2. When we take it up, it's gonna be minus because when it's down, it was because we're forcing it to be positive. And now we've got this f at x, we need to put that x. So this now is in this format because this is f at x, and outside we are multiplying by the derivative of this f at x. So let us apply that rule. X, the inverse of sine x minus. So now the rule says, oh, my mistake here. Here I was supposed to force this to be 2x because that's x squared, then the derivative is 2x. Then that 2, I would take it out and I wouldn't take that 2 out. I would force that thing. When I put 2 there, I must force it to 1 over 2 here. That will cancel that 2 to bring me back to a normal state when I wanted to. So this would be 1 over 2 outside, and this would be f at x n plus n. So here we would have something like 1 minus x squared and minus 1 over 2 plus 1, all divided by minus 1 over 2 plus 1 plus 1. So this leaves me with x minus 1 over 2, and that would be positive 1 over 2. 1 minus x and squared 1 over 2, 1 over 2. What am I writing there now? 1 over 2. So now what is gonna happen with this it's gonna cross multiply, and these two would come to the top now. So let's continue with that. So we'd have x, and now we've got 1 over 2, 1 minus x squared, 1 over 2 times 2 over 1. This cancels that one. So this can also be taken back to a root. So our final answer would be arcsine x What happened with the sign? Okay, let's just rewrite this. I'm just gonna go back carefully and look if I haven't done any mistake with the sign. Let's just change and put the red pen and reconsider the sign. Wow. So the sign was negative. From here, the sign was negative. I'm just double checking because sometimes I do make these mistakes. So negative continued. Here the sign was supposed to change and be positive because a derivative of minus x squared is minus 2x. So we are supposed to be having a negative there. When we force things here, then that sign was supposed to change. So we're supposed to be having positive here and positive here. So don't get too excited when you're doing this and forget the importance of signs.